I am Karthik Kuchar. Today I will be presenting the solution of our internal test analysis covering question 11 and 12. This section focus on data smoothing and integration, two vital steps in clearing and preparing data. This presentation is submitted to Dr. Shaligram Prajapati. Moving on to our first slide, let's start with question 11. We were given a sorted list of feedback rating ranging from 13 to 17. Our task is to smooth this data using bin means with a bin depth of 3. Smoothing is essentially a way to remove noise or random fluctuations from a dataset to reveal the general trend. Bin depth 3 simply means we will group the data into into small buckets, each containing exactly 3 items. Step by step calculation. Bin 1 contain 13, 15 and 16. The average is 14.7. Bin 2 contain 16, 19 and 20. The average is 18.3. We repeated this process for all groups. For example, bin 9 contained the highest value 46, 52 and the outlier 70, giving a mean of 56.0. The smoothing we replace every original number in a bean with its bean's calculated mean. So the first three numbers all become 14.7, the next three become 18.3 and so on. Outlier detection and other methods. We also explore how to detect outliers. Those extreme values that skew our data like 70 in our list. Box plot rule. Any value significant higher than the upper quartile, quartile 3 plus 1.5 into IQR is flagged. Z-score. Any value more than 3 standard deviation from the mean is considered an outlier. Other ways to smooth data include bin boundaries, rounding to the nearest edge values, or regression, fitting a math equations to the trend. Moving on to the next question, data integration. In the world of MCI and MTech analytics, data rarely comes from one place. Data integration is the complex process of combining data from multiple disparate sources into a single, unified view. We discussed three specific challenges in this process. Challenge 1, the schema integration. The first challenge is schema integration, or the name problem. Different databases often use different names for exact same thing. For instance, an exam database might use student ID while the library database calls it roll number. So, what is the solution for it? We create a mapping tables or metadata repository that links these items, telling the system that the student ID equals roll number. Mo- uh, the second challenge is handling redundant data. The second challenge is handling redundant data or the duplicate problem. Storing the same information twice wastes space and risk error. A classic example is storing both date of birth and age. Age changes every year, making the stored value outdated quickly. Solution. We use correlation analysis like person's coefficient to support attributes that are too similar and remove the redundant ones. The third challenge is resolving data conflicts or the value problems, even if the names match, the scales might not. One system might rate students on a 1 to 10 scales while another uses A to F grades. Solution. We must normalize the data. We convert all these conflicting scales to a standard range like 0 to 1 before we combine them, ensuring we are comparing apples to apples. Summary of data smoothing. To summarize question 11, data smoothing is about noise reduction by using binning techniques like means or boundaries. We simplify the analysis. We also protect our analysis by identifying anomalies through outlier detection, ultimately leading to higher data quality. Summary of data integration. To summarize question 12, successful integration requires schema alignment to fix naming issues, redundancy handling, to remove duplicates, and conflict resolution to standardized formats. This results in a unified view that enables deeper, more accurate analytics. Thank you for listening.